All right, chapter 2 test. All right, the first question, it said, determine whether this is a function. Well, 3 is mapped to 3. 4 is mapped to a 2. 5 is mapped to a 2. And 6 is mapped to a 2. So we have 3 going only to one output, 4 going only to 1, 5 only goes to a 2, 6 only goes to 2. So for each domain element or each input, there is only one output, so it is a function. Now some others said you could graph this, and if we went to 3 and put in 3, and 4 had a 2, 5 had a 2, and 6 had a 2. These are the only 4 dots on the graph, and a vertical line cannot hit any 2 points at the same time, so it also passes the vertical line test. So it is a function. A couple ways to do that. This one passes the vertical line test again, or a vertical line hits or crosses or intersects the graph at most 1 point. It's one point over here, no points over here, no points back there, so it is a function because it passes the vertical line test. 3a says, what was the domain in 1? Well, that was 3, 4, 5, and 6. I cannot use interval notation. They're separate numbers. There's nothing in between, so I got to go 3, 4, 5, and 6. I cannot go 3 to 6 because that would include all the numbers in between 4 and 5, like 4.5, or between 3 and 4, like pi, and all those numbers that are in between, an infinite number of them, and there's only 4 numbers, those 4, so you list them. Can't do this. No. Okay, square root. The only thing about square roots is you cannot take square root of a negative number, so that 3 minus x cannot be negative. If it's not negative, then it's either greater than 0, which means positive, or equal to 0. It just can't be negative. Now, if I subtract 3 from both sides, I get negative x greater than or equal to negative 3. And then if I solve for x, then I have to multiply or divide by a negative. Either will work. And I get x, and I get plus 3, but if I divide or multiply by a negative, the sign has to flip over. And so the numbers I can use have to be less than or equal to 3. So that would be from negative infinity up to 3, and including the 3. Or I could write it with a set notation. The set whose elements are numbers such that the numbers are less than or equal to 3 in the set. And finally, C. I have a division problem. The only time we have problem with the division problem is if we divide by 0. I don't care if the numerator is 0. The denominator cannot be 0. So x minus 9 cannot equal 0. Now this is not x squared, so we don't add 9 and then take the square root. It's just x. And if I add 9 to both sides, I get x cannot equal 9. So I can write that as set notation, or I can say all reals except 9. That's the first page. Second page, I heard people say, oh, this is going to be the easy one, and a lot of points missed because you don't know the definitions really well. First of all, it does not ask for the domain, it says range. Read it carefully, don't just go on autopilot when you're doing the test. Range is from lowest to highest. The lowest number is -4. The highest is about 8, but it disappears at 8, so we have to use an open paren. It does exist at -4 or -3.9, so we do a square bracket. And there's no holes leaving gaps in the range. So that's the range. Make sure you read the problem carefully. Now, intercepts. This graph crosses at -1.4 roughly when the y is 0. Intercepts are points, so you have to give me both the x and y coordinate. It crosses at -2.6 maybe when x is 0, -2.6. And then you could either give two different ones here or just say it crosses at about 6.80. Now if you said it crosses at 6.40 and at 70 or something like that and gave me 2, I would be fine with that too. It's kind of hard to estimate that one. I understand that, and if you give me something reasonable, I will be reasonable. Now you need to know how to read this notation. It says m of 3. This m is not a slope because this says this whole graph is m. It's the name of the graph, not the name of the slope. So we're supposed to go to 3. It says find the y value at x equals 3. When we go to 3, the y value is -3.8, let's say. Now I don't do this as a point because it says find the y value when the x is 3. Y value when x is 3. It doesn't ask for the x value. The x value is already given. So -3.8. Then it says find the y value when x is -7. So if we go to -7, the y value is 7. Now a maximum is the y value. Local means it's a place where hot air would trap, or it's higher than its neighbors. Well, this is higher than its neighbors, but it's gone. So, but it's the highest. There's another highest place here, like you might say 0.1 or 0. That's a locally high spot. You can tell me that it's at x equals 7 or 6.8 or something like that, but you don't need to. Just tell me how high it is. If you did 0.1, I would have been fine, 0.2, something like that. Local minimum, that's where the bottom of the puddles, and there's a bottom of a puddle here at about -4. Absolute maximum, there's a very highest place. Well, this keeps going up, and it looks like the highest place is going to be 8, but it disappears. So there is none, because it disappeared. Local minimum, that's the very lowest place, and that lowest place is -4. Or these should be both -4 or -3.9 or something like that. Intervals where it's increasing. Intervals From where to where, and intervals of increasing or decreasing are always with parentheses because you can't include the ends. Looks like it's increasing from negative when x is negative 10 to when x is negative 5.8 or something. Negative 10 to negative 5.8-ish. And then it decreases, and then it starts increasing at about 2.5. And it continues increasing for x's from 2.5 up to about 7, 6.9, something like that. And you never include the ends, put a union. And that's number 4. Number 5. We have two equations, y equal x minus 1. So if I put in 0, I get negative 1. If I put in 1, I get 0. If I put in 2, I get 1. If I put in 3, I get 2. If I put in 4, 1 less is 3. I got a line that's going at a slope here. It's hitting the corners of each of these squares, a diagonal. But I can only graph that when the x coordinates are less than minus 1. Not the y coordinates, the x coordinates are less than minus 1. The x coordinates are minus 1 right there, and they're less over here. So it starts there, not including it. The x coordinates are less than minus 1. Don't confuse the x coordinates with the y coordinates. X coordinates are less than minus 1. X is less than minus 1. Now we draw the other line, y equals 0.5x. So half of 0 is 0, half of 2 is 1, half of 4 is 2. So I've got a pattern going like this. It's the corner of every other rectangle or square. But I only get to draw that for where the x coordinates are between negative 1 and the x coordinate is up to 5. The x coordinate, not the y coordinates, x coordinates. From negative 1, and it's an equal, so it's a solid dot, up to where x is 5, which is there. So I got this piece and this piece. So that's the graph. Now where does this graph touch the x or y axis? The only place it hits is at 0, 0. And this part that I don't use, can't count those. What's the y value at negative 2? Well, negative 2, I'd use this one, and I get negative 2 minus 1, which is negative 3. Or look here, at negative 2, it's negative 3. What's the y value when x is 6? At 6, the lines that are kind of related exist, but the actual graph doesn't exist out there. Or if you look at this goes up to 5, but not to 6. So we don't know what's going on there. So we can't say no solution. That means we were solving the equation. There's just no definition for this. So we say undefined. And at 4, what's the y value? The y value looks like it's 2. Or 4, which is between minus 1 and 1. And so we would use 0.5 times 4, which is 2. That's the answer to that one. 6. We're supposed to do f minus g. So f is x squared plus 3x. Put that in parentheses, minus g, which was in parentheses 2x minus 3. Some of you refuse to put the parentheses on, and then you continually miss them. Can't do much about it if you refuse. Is there anything to distribute here? Nope, so it's still x squared plus 3x, and I understand you thinking that was useless to put the parentheses. But here it says subtract all of this, so we got to take the subtract 2x, and subtract a negative 3, which is plus 3. Combining the like terms, we get x squared plus x plus 3. Multiply them. X squared plus 3x times 2x minus 3. X squared times 2x is 2x to the third. X squared times negative 3 is negative 3x squared. 3x times 2x is 6x squared. And 3x times a negative 3 is negative 9x. There's some like terms, and so we get 2x to the third plus 3x squared minus 9x. Okay, the one that students struggle the most with here. This says replace x plus h, replace in f the x's with x plus h. That does not mean put this in place of x, it means put x plus h in place of the x's in f. So f was x squared plus 3x. And I'm supposed to put x plus h in place of the x's. X plus h into f, not f into x in the x plus h. Minus, and now since I'm subtracting, highly recommended put parentheses. This says f of x, the original one, not g of x. So that's x squared plus 3x. And that's all over h. So x plus h squared, x plus h times x plus h is x squared plus xh plus xh plus h squared. So that's x squared plus 2 xh's plus h squared. H times 8 was 8 squared. I missed that there. Minus all of this, which means minus the x squared and minus 3x, not plus 3x. Oh, and I forgot, I made a mistake. I didn't, like some of you did on the test. There's a plus 3x. Let's get that. 3x plus 3h, and then minus the x squared minus 3x. This is plus 3x plus 3h. Get that all correct. All over h. And now the x squared and the minus x squared cancel. The plus 3x and the minus 3x cancel, and I get 2xh plus h squared plus 3h over h. And I can factor an h out of the numerator. There's an h in each one of these, so that's going to be h times 2x. H times 2x is 2xh. H times h is h squared. And h times 3 is 3h. And now the h over h cancels, and I get 2x plus h plus 3. Now, it says f, which is x squared plus 3x, but we're supposed to replace the x's with 3. This does not say 3 times f divided by g. It says put 3 into f and g, so I got to put a 3 in place of the x's. G is 2x minus 3, and in place of the x I'm putting the 3. So I get 9 plus 9, which is 18, over 6 minus 3, which is 3, and that reduces to 9. 7. So our parent function is apparently, parent is y equals x squared. So I'm hoping that you can draw the x squared properly. 0 squared is 0, 1 squared is 1, 2 squared is 4. Same on the negative side. You get the same positive answers. And label the scaling on it, label your units, and that's the parent. Now, you can do the inside first or the outside first, but you got to do them in proper order. I've asked you to do inside first in class, and so there's two numbers, a times 2 and a minus 1. Order of operations, say you would multiply by the 2 and then subtract 1. But inside you do things opposite, and so you will do the minus 1 first, and the minus 1 on the x on the inside works horizontally. It says minus 1, you would think it'd move it minus 1, but it moves it plus 1. So this parabola ends up going through that point, that point, that point, and 2 over squared is 4, 2 over squared up 4. And so it looks like this, and my description is moved right 1. Now the other number that's inside is the 2, and it's times, so it's either going to stretch or compress horizontally this way relative to the y-axis. Since it's a 2, the times 2 on the inside will do the opposite of making it twice as wide. It'll make it half as wide, so it's going to compress 2 y-axis by 2 times. So this point, 1, 0, is 1 away. Half of that is a half away. This point, 0, 1, is right on the y-axis, so it stays. This point, that's 2 over and up 1, is 2 away, so it goes to half as far, 1 away. And the point up here, about 3, 4, is 3 away, so we go to 1.5 away at 4. And this was a half on the other side, so 1, so it goes to a half. Get my units on. Now that I've got the graph, except for the final thing, the plus 3, which will move it up 3. So I'm going to move my axis down a little bit so I can do this. And so there's 2, and there's 2, and so this was a half 0, and if I move it up 3, it's a half 3. This was 0, 1, it'll go up 3, so it'll be 0, 1 plus 3 is 4. And the other one on the other side there, and then this one that was at 1.5, 4 will be at 1.5, 7. 1, 2, 3, 4, 5, 6, 7. And negative 1/2, 7. And there's that one. Okay. Final page. So we have y equals 2 times f, x minus 1, there's one number on the inside, minus 3, 2 numbers on the outside. This is the parent. It's not a typical one that you had to memorize, but it's a parent. That's what I said it was. So now you need to And I suggested doing inside stuff first. Don't have to, but you do have to do the 2 and the -3 in proper order. But the x minus 1, I'm going to take care of it first. Minus 1. It's inside, so it works horizontally, not vertically. It's subtract 1, so it moves it not the opposite, since it's inside, moves it plus 1. So this one at -3, -1 goes to -2, -1. The -1, 1 goes to 0, -1. It moves it over 1, and this one will be moved over 1. It'll be the same shape, but moved left 1. Put some units on here. Now, the 2 and the -3, both outside. Outside, you do order of operations. Multiplying by 2 means you're going to do a vertical stretch from the x-axis by 2. That doesn't mean move it 2, it's stretch it 2. So this point was down 1 from the x-axis, -2, -1. So it's -1 away, and if you're going to double that, it's going to be -2 away, not 2 more. Double -1 is double -2. This one was 1 above at 0, 1, but you're going to double the 1, which meant 1 times 1 is 2. I mean, 1 times doubling times 2 is 2. This one was at 3, 2, double the 3, 1. And so if you double how high it is, or how far away it is, 1, you get 2. So there's some units, and that's what it does. And that times 2 is a vertical. This works vertically because it's on the outside. A vertical stretch by 2. Stuff below went down, stuff above went twice as far up. And finally, the -3, which shifts it up 3. So this point that was at -2, -2, if you move it up 3, it becomes -2, 1. This point that was at 0, 2, move it up 3, becomes 0, 5. And this point that was at 3, 2 becomes 3, 2 plus 3 is 5. All right, odd and even. Now some of you tried to talk about symmetry. If you're going to talk about it, you better make a good graph of it so that we get the right idea, but let's just look at it. The easier way is just to put a positive and negative number, like put in 2, squared, -2, put in 2 for the x again. That's 4 minus 4, which is 0. Now if I put in -2, -2 squared is 4, and then -2 times a -2 is also 4, so we get 4 plus 4, which is 8. Now we did not get the same number, or the same numbers except opposite in sign, so you have to either get the same answer out, which makes the function even, or the same numbers but opposite in sign, 1 plus and 1 minus, which would make it odd. We didn't get either of those, so it's a neither. We go to this one. If I put in -2, take it time the absolute value, take it times 2 minus 1, absolute value -2, -2 is 2 away from 0, so this is 2 times 2 minus 1, so that's 4 minus 1, or 3. Now we're supposed to put in the opposite. So I put in -2, now I'm going to put in 2. X was only one place. So the absolute value 2 is 2, so I got 2 times 2 minus 1, same thing as we had before, 3. When you get the same result for opposite signs in the inputs, That's called an even function. Alright, so let's see what this one does. If we put in minus 2 and square it and then add 1, I get 4 plus 1, 5. If I put in plus 2 and square it and add 1, that's what it says up here to do, I get 4 plus 1, which is 5. Got the same result, same sign on them, not opposite signs, so this is also even. And the last one. It says write a distance function. Well, the distance between 2 points is the square root of change in x squared, it's a Pythagorean theorem, plus the change in y squared. Okay, and it's supposed to be the distance from the origin. The origin is 0, 0. The point is at x, y, if it's movable. So it's not determined, it's not a specific number, it's not 2.3, it moves. So the distance becomes the square root of the change in x, so x minus 0 is just x squared, so change in x becomes x squared. Change in y, so that'd be y minus 0, so that'd be y squared. Now we're supposed to make this a function of x, but this has a y in it, so we have to do one more step. We need to get the y out of there by replacing it with something. So we got the square root of x squared plus, now up here it said that y was, or f of x was 6 minus 0.3x squared. So all of that is the y. And the y is supposed to be squared, so that whole quantity is squared. And there's the distance formula in place of x. Now to find when the distance is the minimum, you take your calculator and type in that equation, the square root of x squared plus 6 minus 0.3x squared, squared, close parenthesis, and if you push zoom 6 and graph it, it has a minimum out here somewhere around 4 and 5, and so I'm going to find that minimum by going second, calculate the minimum, number 3, and I'm going to look somewhere between 0 and 6, 0, enter, 6, enter, and my guess is about 4, and it says, no, it happens at 3.8. And that's what I asked you to find the x value where you have a minimum distance in the first quadrant over here. So you don't want to do the negative one. Now if I actually asked for the minimum distance, then that would have been 4.15. But I didn't ask for that. So x equals 3.8, the x coordinate that gives you the shortest distance from the origin to the point. And that's the test.